Hey class, Mr. Andrew here. For today's lesson, we're going to be taking a look at section 12.4, which is going to deal with similarity in right triangles. So for today's lesson, we have two learning goals. Our first learning goal is that you will be able to find the geometric mean of two numbers. And then the second one is that you will be able to use the geometric mean to help you find missing side lengths. So we're going to talk about what the geometric mean is, and then we're going to use that to help us find missing side lengths for similar right triangles. So that's how we're going to take a look at similarity in right triangles. Now, first thing that we need to take a look at is the geometric mean. So let us do that first. Consider the proportion a over x equals x over b, where two of the numbers in the proportion are the same. The number x, in this case, would be the same. So the number x is the geometric mean of a and b. So if, let's say, we set up a proportion, we have a over x equals x over b. So x represents that same number. So if we have two numbers that are the same, that's considered the geometric mean of a and b. So it's kind of not necessarily just the mean, but the geometric mean. Now, the geometric mean of two positive numbers is the positive square root of their product, meaning you would multiply those two numbers together and take the square root. So the geometric mean of a and b is the positive number x, such that x equals the square root of ab, or x squared equals ab. So when you are asked to find the geometric mean of two numbers, that means you go through and multiply those two numbers and then take the square root to figure out your answer. So with that said, let's go ahead and get into our examples for today. Now, example one would just have us go through and write a similarity statement comparing three triangles in each diagram. I will leave those there for you to look at. They are done in my completed notes if you just want to see what they are. If you have questions over how to do those, just let me know and I'll be more than happy to explain or help you understand them. But for our purposes in our time today, I just want to move on to the geometric mean. So again, geometric mean is x, and to figure out that value, you take the square root of AB. So if we take a look at example 2, they want us to go through and find the geometric mean of the two numbers and to simplify if necessary. So what that means is when we get to the square root, if we don't get a whole number after taking the square root, that means we need to simplify the square root. So if we look at example 2, part A, we have 4 and 25. We want to figure out the geometric mean of those two numbers. So to figure that out, if we have x equals, it's the square root of the product of those two numbers. So it's going to be the square root, and product implies multiplication. So it's going to be 4 times 25. So we're going to take the square root of 4 times 25. So the first thing we need to do is go through, figure out what 4 times 25 is. So if we do 4 times 25, we end up with 100. So we now have x equals the square root of 100. So if we were to take the square root of 100, we would end up with 10. Now, because this is a whole number and it's not a decimal, say like 6.34, if you ever have a decimal, we don't want the decimal. They asked us to simplify, so we'd have to simplify the square root. Because this is a whole number, 10, that means my answer is just 10. We don't have to worry about simplifying the square root because that is as simplified as our answer can get. So x equals 10 is the geometric mean of 4 and 25. And that's our answer for part A. All right, for part B, they want us to go through and figure out the geometric mean of 9 and 20. So we're going to set this up much like we did A. So we're going to have x equals the square root of 9 times 20. So we do 9 times 20, and we end up with 180. So we have x equals the square root of 180. If I go through and take the square root of 180, we would end up with 13.416 and so on. So this is where the simplifying comes into play. I cannot just put 13.4 as my answer unless it were to ask you for the geometric mean as a decimal. Then you would round to wherever they want you to round. So that would be like 13.4. But they want us to go through and simplify the square root. So I need to simplify this 180, or the square root of 180, down as far as I can. So in case you do not remember or you haven't been taught how to simplify square roots, what you need to do is take the perfect squares, and we're going to figure out what is the largest perfect square that we can divide into 180. So we're going to keep 180 in mind, and what I need to figure out is what is the largest perfect square that divides into 180. Now, what are perfect squares? They are numbers that if I went through and just did 1 to the power of 2, I get 1. 2 to the power of 2, we get 4. 3 to the power of 2, we get 9. So they're numbers that if I put to the power of 2, okay, this would be 1, 2, 3, 4, and so on. There are also numbers, if I chose any of these numbers, say 49, I get a whole number. So these are numbers, perfect squares are numbers that if you take the square root, you would get a whole number as your answer. Now, I stopped my list at 144 just for matter of space, but these can continue on forever. This is 12 to the power of 2. You can do the same thing for 13, 14, and so on. So if we have 180 as our number in mind, we need to figure out what is the largest number that can divide into 180. Now, just for matter of reason, 144 is not going to go into it evenly. Neither is 121, 100. We could check 81. It's pretty close. But 81 is not going to work. So then, if we continue, so 180 divide by 64, I get a decimal. 180 divide by 49. Again, I get a decimal. Keep going down the list. So 180 divided by 36, and we end up with 5. So 36 is going to be the largest perfect square that we can divide into 180. So that means we're going to represent this as the square root of 36 times 5. Now, to further simplify, okay, because 36 is the perfect square, we can take the square root of that. So if I take the square root of 36, we end up with 6. And 5, I can't take the square root of. Okay, it's not a perfect square. It's just going to give me a decimal. This is kind of considered our remainder. So we're just going to leave this as the square root of 5. So 6 times the square root of 5 is going to give us our answer for the geometric mean between 9 and 20 if we are simplifying the square root. So again, when you are going through and simplifying a square root, and we'll practice another one, you have to figure out what is the largest perfect square that we can divide into this number. Okay, in this case, we found it to be 36. And then that remainder part 5 is going to remain as the square root. And then the other part should simplify down to a whole number. So 6 times the square root of 5 is our answer for part B. All right, so to go through and continue our practice, for C, we need to find the geometric mean of 6 and 24. So if we go through and do this for part C, again, we're going to have x equals the square root of 6 times 24. If we do 6 times 24, move that up. 6 times 24 is going to give us 144. And if we check, if I take the square root of 144, we end up with 12. So because I do get a whole number, that is our answer for part C, that x equals 12. So if you ever get a whole number, that's your answer, and you don't have to worry about simplifying, and then you're good to go. So that is our answer for part C on the geometric mean of 6 and 24, as it is 12. All right, now for part D, we need to go through and figure out the geometric mean of 5 and 12. So if we go through and set this up, we're going to have x equals the square root of 5 times 12. 5 times 12 is going to give us 60. So x equals the square root of 60. If I take the square root of 60, we're going to end up with 7.74 and so on. So because that gives me a decimal, that's not what we want. So we need to go through and simplify this just like we did for part B. So 60 is our number. What we need to figure out is what is the largest perfect square that divides into 60 evenly. So keeping 60 in mind, we're going to pull out our list of perfect squares again. If you don't write down a list of perfect squares, you can always Google and find out what they are. And you could also probably Google what is the simplified square root of the square root of 60 as well. So 60 is our number. We need to figure out what is the largest perfect square that goes into 60. So keeping 60 in mind, we're going to go to the first number that's less than 60, which is 49. Now, reason would state that it's not going to divide in evenly, but if I did 60 divided by 49, we get 1.2. So if we continue on down the list after 49, so 60 divided by 36 is going to give me 1.6, so that doesn't work. We do 60 divided by 25, we end up with 2.4. We are oh so close, but that doesn't work. If we do 60 divided by 16, we get 3.75. Again, we're close, but not there yet. So if we do 60 divided by 9, we get 6.6 repeating. Still not there. So then the last one we're going to be able to try is 4. So if we do 60 divided by 4, we get 15. Or we get 12, sorry. No, 15. So if we do 60 divided by 4, we get 15. My apologies. So that is going to be our largest perfect square that divides into 60. The one thing I want to note, if you got to the point where 4 did not work, so let's say 61. If I divided by 4, okay, that gives me 12.25. That doesn't work. So if you were to ever get through your whole list of perfect squares and you don't ever get it to divide evenly, then that number, say 61, would be your simplified square root. So understand this. If you run through all the perfect squares, okay, don't think about 1. 1 is a perfect square, but 1 divides into everything. Okay, So just know that if you make it through all the way, if you get to 4 and it doesn't divide in evenly, then that number is your simplified square root. Now, in this case, we got 4 to divide in evenly to 60. So what that means is we now have the square root of 4 times 15. I can take the square root of 4, and we get 2. So that means our answer is 2 times the square root of 15. And that is our answer for the geometric mean of 5 and 12. So if you get a whole number when you take a square root, that is your final answer, as we saw with parts A and C. If, like with parts B and D, you get a decimal, you need to go through and simplify. To simplify, you take your list of perfect squares, you figure out what is the largest perfect square that divides into that number. For 180, it was 36. For 60, it was 4. Again, if you run through your list and there's not one single perfect square that divides into these evenly, okay, let's say 180 didn't have a number. That means my answer would just be the square root of 180. Same thing for 60. If 60 wasn't divisible by 4, my answer would be the square root of 60. So understand, not every number can be simplified by a perfect square. But if it can, okay, in this case it was 36, so we have 36 times 5. Take the square root of the perfect square. That number goes out in front, and then the other number remains in the square root. So with that said, that is how you do example 2. I know that was a bit longer on one example, but I just wanted to refresh your memory on how to simplify square roots. So with that said, we have one final example remaining, and that is example 3 on using the geometric mean to find side lengths. So before we get into example 3, what we need to do is talk about the geometric mean theorems. So there's 2 theorems using the geometric mean to help us find different side lengths. So the first one is the length of the altitude to the hypotenuse of a right triangle. So when they talk about this length of the altitude, that's going to be this right here. So the line that is going to go through the middle, it's going to be considered like the height of the triangle. So this line right here, which in this case for example 3 would be x right here. So this line is considered the altitude of hypotenuse. So another discussion at a different point. So to figure out this length of h, okay, what you would have to do is take the geometric mean of the lengths of the segments of the hypotenuse. So the segments of the hypotenuse would be x and y, so that's these 2 parts. So to figure out the value of h, it's going to be the square root of x times y. And that is how you figure out h. So if you're trying to figure out h, it is the square root of x times y. Again, if you're trying to find this length right here, it's the square root of this part times this part. You don't need to use the legs at all or the whole hypotenuse. Now, for the second one, it states the length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse in the segment of the hypotenuse adjacent to that leg. For example, if I wanted to figure out the length of A, it's the geometric mean of the whole hypotenuse, C, and then the segment of the hypotenuse that is attached to that triangle with that leg. So if we're talking about A here, that segment between x and y that is related to A is x. So you would use x and C. Now to figure out B, we would use C and y. So to figure out A, you're going to use this part in the whole hypotenuse. To figure out B, you're going to use this part and the whole hypotenuse. So you're always going to use the whole hypotenuse to figure out one of the legs, and then you want to use the other smaller segment of that hypotenuse that touches that leg. And we're doing the geometric mean, so that means that we are taking the square root of those two numbers multiplied. So understand, when it goes through and asks us for example 3 to find the values of x, y, and z, okay, we're going to use the geometric mean, which means we're going to multiply two numbers together and take the square root. So what I want to do is go through and practice that, and hopefully you'll have a better understanding of how to do it. So for example 3, they want us to go through and find the values of x, y, and z. So we have x, y, and z, and then we have 10 and 2 also in our diagram for A. Now, the first thing I'm going to do is figure out the length of x. So this is considered our altitude of the hypotenuse. So to figure out x, remember this is the line that went through the triangle. So it would be the geometric mean of these two numbers right here. So to figure out x, it's going to be x equals, geometric mean is the square root of these two numbers multiplied. So 10 times 2. So if we do 10 times 2, we are going to end up with 20. So we get x to equal the square root of 20. Now, if I went through and checked square roots of 20, we get 4.4. So that is not fully simplified. Now, if we were to go through and take our list of perfect squares, okay, if we start at 20, 16 does not divide into it evenly, neither does 9, but 4 divides into 20 evenly. So that's going to give us x equals the square root of 4 times 5. And if we take the square root of 4, we end up with 2. So x is going to equal 2 times the square root of 5. Now again, how I figured out x, when you figure out the line that's going to go through the triangle, okay, consider this like as the height of this triangle, to figure out the length of this, the value of the x, you're going to take these two numbers, multiply them together, and take the square root. Alright, so that is how we find x. Next, let's go through and figure out the value of y, so to figure out the length of that side. So to figure out y, it's the geometric mean, the length of the hypotenuse, and that segment adjacent to that leg. So the entire hypotenuse is going to be this whole segment right here. Segment addition postulate states 10 plus 2 is going to give us 12 for the whole thing. So to figure out y, we're going to use the whole hypotenuse length, which is 12, and then the segment that's close to y, which is 10. So to figure out y, it's going to be the whole hypotenuse times the segment that is adjacent or next to y. So that's going to be the square root of 10 times 12. So if we do 10 times 12, we are going to end up with 120. So if we have 120, if I take the square root of 120, we end up with 10.9. So that is not going to just be a quick answer on that. So what we need to do is go through and figure out if we can simplify. So using our list of perfect squares, we start at the number just less than 120. So we have 100. That does not divide evenly. We do 81. that is not going to divide evenly. And just to save us time, if I were to go through all these, it is going to end up at 4 as the largest perfect square that divides into 120. So when I go through and do that, we get the square root of 4 times 30. If I take the square root of 4, we get 2. And then we're just going to be left with the square root of 30. And that is the length of y, or the value of y for this problem. All right, so the last one that we need to figure out the value of is z. So we need to figure out the length of that side length. Now, in theory, we could use the Pythagorean theorem, because we know y and we know the hypotenuse, and because we have a right triangle, we could do a squared plus b squared equals c squared to solve it, which I have done in my notes. For this one, though, I'm just going to use the geometric mean. So to figure out z, to figure out the value of z, it's going to be the geometric mean of the hypotenuse, which is 12, and then this segment that is next to z. So to figure out y, we used the segment next to it, which was 10. So if we're going to use the segment next to z, it's going to be 2. So z is the square root of 12, the hypotenuse, and then the segment next to it, which is 2. So it's going to be 12 times 2. If we do 12 times 2, 12 times 2 is going to give us 24. Now, if I take the square root of 24, we end up with 4.8 and so on. So I'd have to go through and simplify this again. If we look at this list of perfect squares, okay, if we're thinking 24, 16 is not going to divide into it evenly, neither is 9. So if I did 24, just to prove 9 doesn't, if I do 24 divided by 4, we get 6. So that means I can break 24 into the square root of 4 times 6. Square root of 4 is going to give me 2, and then I cannot take the square root of 6. So that is our answer for z. And that is our answer for example 3, part A, for how you figure out x, y, and z. So that is really kind of the gist of what we are doing today. I just want to run through B just to give you another reference problem to look at and to reflect back at in the video as you go through and do your homework. So I'm going to slide this up, and we're going to take a look at part B. So I'm going to cover up A, just that way we can focus only on part B. So again, we need to go through and figure out x, y, and z. So if we look at x, again, x is this line going right through the middle of the triangle. To figure out the value of that length, if you were ever asked to figure out the length of this, okay, we're going to take these two numbers and multiply them together and take the square root of that. So x is just the square root of 5 times 7, which in this case is the square root of 35. Now, I'm just going to stop there for right now. I'm not going to go through and simplify for the moment. I just want you to understand what two numbers we need to pull for x, y, and z, and then we can go from there. So to figure out x, it's just 5 and 7 to give us the square root of 35. Now for y, to figure out the value of y, We have to take the whole hypotenuse. 5 plus 7 is 12. So to figure out for y, what we're going to do is take the whole hypotenuse, which is 12, and then the smaller segment, which is 5. So it's going to be the square root of 5 times 12. And if we do 5 times 12, we end up with 60. So we get y equals the square root of 60. So again, why I chose 5 and 12 for my numbers for y is because you have to use the whole hypotenuse and the segment that is next to the value you're trying to find. So because I'm trying to find y, that's next to 5, so that means I want to use 5 and then the whole hypotenuse, which is 12. Alright, for the last one, which is z, to go through and figure out z, I'm going to do much of the same thing that I did for y. So we're going to use the whole hypotenuse, which is 12. And then I want to use the segment that's close to z, or next to it, which is 7 in this case. So if I did 12 times 7, we would end up with the square root of 84. So hopefully with this problem, you get a better feel of how you go through and pull these numbers out for each one. So again, to figure out x, you have to use these two segments. For y, you use the whole hypotenuse and then use the segment next to y. For z, use the whole hypotenuse and the segment next to z. And that is how you go through and figure out your values for x, y, and z. Now, we went through and multiplied, so we got x to be the square root of 35, y to be the square root of 60, and z to be the square root of 84. Now, if you went through and calculated all these out, you would see we get a decimal for all of them. So unfortunately, that means that we don't get a whole number for any of our answers. But just to kind of save time, know that x is the square root of 35. There is no perfect square that divides into 35 evenly. For y, the square root of 60, we actually did on the front side for example 1, part D. And the simplified version of the square root of 60 is 2 times the square root of 15. And then for z, so we have the square root of 84. If we went through and simplified that, we would get z to be 2 times the square root of 21, which means 4 is the largest number that divides into 84, leaving us with 21. So the square root of 4 is 2, hence 2 times the square root of 21. All right, so that is how you go through and do part B of example 3. So I hope this was helpful for you today and that you have a decent understanding of how to find the geometric mean, where you just multiply two numbers together and take the square root, and then also how you use the geometric mean, as we saw in part B and A for example 3, to go through and use the hypotenuse in the segments of the hypotenuse to figure out the values of x, y, and z. Also, we talked about how to go through and simplify square roots. I hope you feel comfortable with how to simplify them. I know they are not the most fun. It's not something we're going to do a ton of. Hopefully and likely it will just stay in this section and for that quiz. Know that if you ever need help simplifying square roots, please just come to me and let me know, or shoot me an email, and I'll be more than happy to walk you through it or try to explain it. You could always Google how to simplify square roots, or you might be able to just Google what is the simplified version of the square root of 60, and it might give you a result on what it is. So you could always Google that or look on the internet on figuring out the simplified versions of 35, 60, and 84, and you could find that to be more of help. So with that said, that is it for our lesson today on section 12.4, which dealt with similarity in right triangles. And know that section 12.4 is the last section of module 12, which means that a quiz is upcoming. So be on the lookout for that. Thank you guys for listening. I hope this was helpful. As always, as you were working on your homework, be sure to look back at the completed notes for some guidance. And if you have any questions, as always, just let me know either next time you see me or via email, and I'll be more than happy to help. So that is all for today. Thank you guys for listening, and have a great day. All right, bye.